All right, so this video is about imaginary numbers, so about I. Remember that we define I as being equal to the square root of -1. So remember, the square root of -1 would also be equal to I. This means that I squared is going to be equal to -1, okay? So the square root of -1 is equal to I, and I squared is equal to -1. Those are really, really, really important things that you have to be able to remember. So I wanted to show you some problems where we have a negative inside our square root, because when we have a negative inside of our square root, we have to do something special with our imaginary numbers. So if we look at this first problem, if I have the square root of -25, well, you can break this down into thinking of it as like the square root of -1 times 25, which would mean that the square root of -1 would be I, and the square root of 25 is 5, so the answer would be 5I. I don't like to think of it like this way. I think it takes a lot of time. So I just like to think that whenever there's a negative, I'm going to pull out an I into my answer. So if we look at this next problem, let's do the square root of -100. Well, I just need to take the square root of 100, which is 10, and I have a negative, so remember I pull it out as an I into my answer, and the answer to the square root of -100 is equal to 10I. So just think, whenever you have a negative, you're going to have an I in your answer. A negative inside your square root, then you're going to have an I in your answer. I want to show you another square root problem where it's negative but not a perfect square. So we're going to have to simplify the radical. So let's say the square root of -32. Okay? So this is not a perfect square. So there aren't two numbers that are the same that multiply to be 32. Like here we had 5 times 5 equals 25. 10 times 10 equals 100, but we can't do that here. So I'm first going to break this up. I'm going to make my factor tree, and two numbers that multiply to give me 32. The first ones that I think of are 4 and 8. 4 times 8 is 32. Then I break this down into 2 times 2. This one breaks down into 4 times 2. And this one breaks down into 2 times 2. So I've broken everything down in my factor tree to where the only numbers that multiply to these guys on the ends is 1 times the number. Like 1 times 2 is 2, but nothing else. So I'm going to circle my pairs. I have a pair right there. I have a pair right there. Okay, since I have 2 pairs, that means I have 2 that comes out for this pair. My second 2 comes out for this pair, and I'm left with this 2 inside. Now, don't forget, there's a negative, so I'm going to have an I in my answer. And if I simplify this, 2 times 2I is equal to 4I root 2. So the square root of -32 is equal to 4I root 2. Because whenever we have a negative in our square root, it comes out as an I. I'm not going to do any with the quadratic formula, but remember when you use the quadratic formula and you end up with a number in your square root, I want you to simplify that number. Okay, there is one more thing, actually a couple more things I want to show you with I, so I'll move to this side of my paper. We can multiply binomials. So when I say binomials, we can multiply 2 sets of parentheses together, even if they have an I in it. So let's say we have the problem like 3 plus 3I times, sorry, you can't see that. 3 plus 3I times 2 minus 4I, something like that. Then I FOIL this just like if it was a regular number. And just like x times x is equal to x squared, I times I is equal to I squared. So we do 3 times 6, 3 times 2, which is 6. 3 times -4i is -12i. Then we end up with a plus 6i, and then a minus 12i squared at the end. Okay, this I squared on the end. Look over here. I squared is always equal to -1. So to simplify this, I need to make that -1. So I'm going to rewrite this. And now on the end, I have -12 times -1. They're being multiplied. Okay, I'm going to simplify this more. So I have 6. I'm going to combine these like terms. So it's -6i. And then at the end, I have plus 12. That's not my answer because I can simplify further by combining my 6 with my 12. So the answer is going to be 18. Oops, that should be a minus sign. Minus 6i. So remember, you just multiply them out regularly, but when you get this I squared, you have to substitute in -1, and then you combine like terms. Okay, the last thing that I want to show you with I is I like to call it the wheel of I. So we use this wheel of I when we're given I to some power. So let's say it was like a really big power, like 50. So we're going to be able to simplify I to the power of 50 using this wheel of I. So in the wheel of I, we have just I to the first power, I squared, I to the third power, oops, and I to the fourth power. And we don't go any more than that. We go 4 times. I remember that easily because 4 is my favorite number. Hopefully you can think of a way to remember that. Okay, now I is just equal to I. I squared is equal to, you should know this, -1. I cubed. Okay, I'm just going to tell you I cubed is equal to -I. Ooh, hold on. Whoops, sorry. I cubed is equal to -I. And that is because if we look over here and I did I cubed is the same thing as I times I times I. Well, right here, I squared is equal to -1, and -1 times I is equal to -I. Anyway, so I cubed is equal to -I. Remember that. And then over here, I to the fourth power is equal to 1, and kind of the same thinking if we had 1, 2, 3, 4 i's being multiplied. That's I to the fourth power. Right here, this is equal to -1 because I squared. There's the square because there's 2. 2 right here, so -1 times -1 is equal to 1. That's why I to the fourth power is equal to 1. Or just memorize these if you're worried about this stuff. So now that I have this wheel of I can solve any problem that has I to an exponent. So to do this, we're going to look at I to the 50th power. So to do I to the 50th power, we're actually going to do 50 divided by 4. But we're not going to do it on a calculator because we don't want a decimal number. We just want to find out how many times 4 can go in evenly to 50, and then we want to find out what our remainder is. So 4 can go into 50 12 times evenly because 4 times 12 is 48. So that means we're left with a remainder of 2. R2, remainder of 2. So this remainder of 2, that's what's going to be left on our exponent of I. So my remainder of 2, so I write I and I use the remainder exponent up here. And I squared, I can look at my wheel or just remember that I squared is equal to -1. So that is my answer. We'll do one more to practice that. So let's say that we have I to the, I don't know, 19th power. So remember, the first step that we do is take our exponent and divide it by 4. And we don't want a decimal number, we just want to find out how many times 4 can go into 19 evenly. So 4 can go into 19 evenly 4 times. Oops, sorry. And that leaves us with a remainder of 3. My paper keeps moving, so it's not letting me write it. Okay, 4 remainder of 3. So that remainder now becomes my exponent on my I. And then I remember my wheel of I, and I know that I cubed is equal to -I. Ooh, that's not a very good I. So this means that I to the 19th is actually equal to I right there. Okay, that would be your answer. Same up here. So this I to the 50th power is going to be equal to -1 because of all this work that we did over here. Let me know if you have any questions. Thanks.